Hey friends, it's Mr. Rogers here, and I want to talk a little bit about active transport today. So active transport is the opposite of what we just did with passive transport. And passive transport did not allow or did not use energy and move particles high to low. Active transport is going to defy this basic principle of the universe, and it's going to move particles low to high. And to move particles low to high, that requires energy. And this energy spent is going to be ATP. Now, there's three ways to do active transport. It kind of got cut off up here, so let me switch to this guy. There's three types of active transport. Small particles moving from low to high concentration is the first one. Honestly, we usually call this a pump. We're going to look at a lot of sodium, potassium pumps the next couple of days, and so I want to make sure that we understand kind of what this looks like here. Okay, so this is just a basic picture of a pump. We need to move these green particles, whatever they are. You can pick anything you want in your head across. Even though there's a low concentration in here, a high concentration here, the cell needs more. And so we have to spend ATP to do that, to make sure that we break this active transport. Also, we need to make sure that this particle is unable to get through this cell membrane. Because if it can just get through, then we spent energy for it to get in, and then it just like falls back out. That'd be pointless. Now, the other two kinds of active transport is endocytosis and exocytosis. Endo meaning to come in, exo means to leave, cytosis, cyto means cell, cis means process. So endocytosis is bringing in something in the cell process, okay? Sending something out of the cell process. So endocytosis, there's two kinds. There's phagocytosis, which is cell eating, and pinocytosis, which is cell drinking. They are identical of each other. It just depends what you're bringing in. If you're bringing in a solid, it is called cell eating. If you're bringing in a liquid, it is called cell drinking. So what happens here is a bunch of particles come next to the cell membrane. The cell membrane, usually one of these guys will connect to a receptor, and this is a receptor response. So it's almost like cell communication here. But one of these guys comes to the receptor. The receptor says to the cell membrane to start folding in on itself. It creates a circular space, and this ends up becoming a vesicle. So this is the vesicle here, and it's containing the things that got brought in. And so this is, we'll say these are solids, that would be phagocytosis. If these were actually liquids, it'd be pinocytosis. Again, it's just what you bring in. If you're bringing in a solid or a liquid. Exocytosis is just the mirror image of endocytosis. You're going to have a vesicle or vacuole, I guess, if you're in a plant, that comes up towards the surface, connects to the cell membrane, opens up, and releases the objects. That's leaving through exocytosis. Both of these require energy. Both of these require the cell to do something. Both of these are sometimes called bulk, B-U-L-K transport, bulk transport, because we can move a lot of things in and out of the cell really quickly. But again, this requires a lot of energy. So this is not something you just do lightly. This is something that's a major component of a cell. For a cell to do this, it's a big decision. It requires a lot of energy. So we have active transport through pumps, endocytosis, exocytosis. Today, for your activity, it's quite straightforward. I'm going to have you guys draw a picture of a sodium potassium pump and do some notes. It shouldn't take too long. Don't get too over complex with the picture. We're going to talk about it tomorrow in tomorrow's notes. But I really just want you to go through, draw a good picture, put in some things that are basically going on there. And we're going to use these next week when we come back from Thanksgiving to kind of explain one of the major processes in your body that we need to kind of understand in this class, but also that kind of drive you as a human being. And that's something called action potentials. And so we have to understand this process of sodium potassium pump to be able to understand action potentials. So thanks for watching. I appreciate it. And make sure you guys do your drawings. Talk to you soon.